Swites or no switesing? Okay. Geometry, honors geometry, Fun Talk Friday, 31st this month, okay? We don't need to add it. Okay. SMBA students will be able to, it says start at 6.1. What we're going to be doing today, guys, is we're going to use perpendicular bisectors and angle bisectors to find measures. We're going to use perpendicular bisectors and angle bisectors to find measures, okay? First things first, unrealistic, okay? But second thing second, let's write our name on here. Wait, how did I already earn the side? We are like 30 seconds into this notes and I already earned the side. That was fast. Yeah, that might be a new record, honestly, though. Okay? I should go for the record every day. See how fast I can earn the side every single day?
Okay, I will give it straight to you whenever you walk in that door because that's how I'm just taking whenever you walk in that door.
So, perpendicular bisector. It's a segment, ray, line, or plane, segment, ray, line, or plane that is perpendicular to a segment at its midpoint. It's perpendicular to a segment at its midpoint. So if it's at its midpoint, it cuts the segment into two congruent parts, into two congruent parts. It cuts the segment into two congruent parts. That's what it means by bisecting, right? It cuts it in half. Okay. Hey, Kevin. Yeah. We'll take this out, please. Okay. I also just like stabbed my face, almost like my eye was as I did that. Okay. No. Okay. So here in this picture, line PC with the arrows on the top, okay, is a perpendicular bisector of what? In the picture to the right, line PC is a perpendicular bisector of what, Sarah?
Line segment AB.
Yeah, line segment AB. Very good. Okay. You can tell because we have the right angle showing it's perpendicular, and these tick marks showing it's congruent. Okay. So that's a review, right? We've learned what a perpendicular bisector was before, right? Okay, or at least we've learned parts of perpendicular and bisector. Okay. Yes, Sarah.
Did you do CP?
Yep, you can do line CP. Yep. You also can do segment BA. Yeah.
Where the frick did P come from? There was A, B, C, P, Y.
Oh, you want me to? You said Y?
Funny.
Don't say it either. Do it.
You can stand in the corner if you want. It might be warmer.
Low key though, that corner is actually more than
Do you know why it's warmer?
You don't know.
90 degrees.
Stop written.
Stop, Trent. It's up to code. They got building code, so it has to be 90 degrees.
Yeah, you sure.
I should just like put like just like right in here, like take like a marker like low key and write it in there.
Why not just like stand in this as our calculator?
180 degrees? That'd be too hot for me. Man's not hot. Okay. Perpendicular bisector theorem. We have like theorems for like everything in geometry. Okay. Geometry's a bunch of theorems. Yes, Taylor.
If 180 degrees is too warm, then why are you not burning up? Because technically that wall.
Yeah, you're like right up.
That's why I'm standing a little bit away. There's giving it a little bit of space for the heat to dissipate.
What about the floor you're standing on?
The floor is lava.
Hey, you just jumped on his free hand.
There it was. I was waiting for that one. Okay, the floor is lava. Okay. You guys remember those like the floor is or like the floor is lava memes? This is like probably like
The floor is Mr.
5 years old. Yeah, those were old. Those are so good though. Man, what a good time in the life of memes. Okay. Think about it. We could have been alive at any time in history, but we've been blessed to be alive at the same time as memes. Oh man, we are so lucky.
I'd rather be alive in the
Okay.
13th.
Like seriously, like that's a blessing right there. Okay, go away.
No. It's like that weird uncle. He never leaves.
I feel that. Your uncle never leaves.
Weird uncle.
Perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, if the point is on the perpendicular bisector of a segment, then it is equidistant, which means the same distance. Okay, talking these end from the two endpoints. Of the segment, equidistant. Equidistant.
Why? Okay, I have a question though.
People always say that. They're like, I feel like, why don't you just say equal distances? That's what it means, equidistant. It's like equilateral, equiangular, equidistant. Okay?
But like, why are the words
Rowan,
so
you're
hard?
giving me like your
Just,
slightly
let's
uncomfortable
make
face.
some
Okay. You're just always slightly uncomfortable.
Because I accidentally
You get
said
pulled over,
movement
like,
instead of act.
A cop asks you how fast you're going. Like, I don't know. How fast? Like, you pulled me over for a reason. He'd probably pull you out of your car and be like, you talk for some reason.
Yeah.
I don't.
What? How did this come up?
I don't know. Your dad jokes are probably gonna get you in trouble.
No, I don't make that dad joke. That's rude.
But
I think your dad jokes will get you in trouble.
I'm gonna ask her if she can
Anyway.
just.
So in this picture, we have the same picture we had up here a moment ago. We're getting way off track. We have the same picture we had a moment ago. See, line CP, the perpendicular bisector. Well, point C is on the perpendicular bisector. So according to the theorem, since point C is on the perpendicular bisector, it has to be equidistant from the two endpoints. So it has to be equidistant from both C and from B. It has to be equidistant from both. Because it's on the perpendicular bisector of the segment, it has to be equidistant from both.
Dang, Mr. Foster, my line is worse than yours.
That's saying something. Jeepers.
Yeah,
Okay.
I don't know why the pictures in the line thing.
Yeah.
Okay, I just need to figure this out.
That takes too much time.
That's the thing.
Hey, what would we also know about point X? Is point X on the perpendicular bisector? So what would be true about point X? It's equidistant from where? A and B. So this is also equidistant from A and B, right? Yeah, that would also be true. Okay. Could we keep going, and if we extended this perpendicular bisector since it's a line, could we make this point, I don't know, Q? Could we make that equidistant from these as well?
Yes.
Sure.
Yeah. Well, I mean, your line wasn't straight.
Pretend.
Nah.
I continue the arrow so it's implied that it's a part of the line.
Now you have two
Oh,
arrows,
I'm
so it's
running
like,
on the wrong one. Oopsies.
Question on that.
No.
Gucci gang. Okay. Hey, what's the converse mean, guys?
shoe.
Besides the shoe. Opposite how?
They're switched.
Switching the order. Okay, we're gonna switch the order because we're gonna have a perpendicular bisector. Converse. If a point is equidistant from the endpoints of the segment, if a point is equidistant from the endpoints of the segment,
Please tell me this isn't gonna be a shoe.
then it lies on the perpendicular bisector of the segment. Probably shouldn't use green right next to green. Okay. So what we're saying here is if XA and XP are congruent, then X has to be on the perpendicular bisector. We're saying X has to be on the perpendicular bisector of segment AB. Okay, I should use a different color for that so it sticks out.
How do you write your B? Upside down. Why? No.
What? No.
I feel like that's normal.
No,
No.
that's not normal.
What are you trying to do? Bisector of A versus
First of all,
Oh,
y'all
wait,
are
no, I
like,
get it now.
too many of you right away were like, it's not. Okay, rude.
Okay, it looks like a B, so you do a hard B.
No.
Reasonable. Okay, sorry. Let me do a Betsy B here real quick, okay?
No, we
Okay,
don't need to
you
do
ready
that.
for this? You ready? Actually, I'm not even sure how you do it.
That's pretty accurate. What's wrong?
That's really very accurate. That is very much accurate.
Shut up, it doesn't.
Yeah, they connect.
There's a careful ending. There's a careful ending to it, okay? But it's different if you write your name versus if you're writing B in a sentence. I noticed that. Like when you're doing like on your points, for example, like when you wrote the B, like like it was a lot smaller. Okay, so like Betsy's like when she's like writing her name, it was like this. Okay, but then she was writing it like triangle A B C. She'd write it like this, and like a lot more concise. Like it looked like more thin. Like you know what I mean? Like you did that. I was like, whoa, it is different. Okay.
It looks like you got a stroke in the middle. You're right.
Let's just
you just had a stroke.
let's just go back around here real quick.
We didn't
That's just gonna be easier. Betsy, by the way, as much as I joke about your B's, I do think they look really cool. Just so you know, like I never have trouble telling your handwriting either. Like I always know, like it's clear, it's concise. Like I always know what you're trying to say. So that is nice. I just think it's unique, and so I'm like, whoa, and I've just never seen it. So anyway,
How often do you
wait,
say
no,
that?
I don't actually think there's anything wrong with it. I just think it's unique.
Maggie does, she makes fun
That sounds about right.
It's fine. My season might easily
Yeah.
exact.
Well, I mean, Maggie sometimes can be a rat, but
Oh, sometimes.
see, yeah. But she's overall nice. Maybe, from what I know.
No.
So, okay. So anyway, if yep, we get the converses as well. Any question on the converse? We get way too on topic. Okay, let's get back on topic.
That's never a good class.
No, this isn't my class.
No, it's on top.
In the diagram, line RS is the perpendicular bisector of segment PQ. Line RS is the perpendicular bisector of segment PQ. Find the measure of PR. Okay? What information could we mark if we know line RS is the perpendicular bisector of segment PQ?
90 degrees even marks around that.
90 degree marks around X.
That's what I said.
What else? Dashes where? PS and SQ. Perpendicular bisectors. Bisector means cut in half.
Yes.
Whoa,
whoa.
Yo, low-key just reminded me of my dad.
Okay? What do we know about this point R that is lying on the perpendicular bisector? Okay, it's doing the bisecting. But what do we know about this compared to the endpoints of the segment
They're
PQ?
equidistant.
It's equidistant. So what do we know about these?
They're congruent.
They're congruent. So what can we do to find X?
Side, or side, equal side. No, equal side,
Take that out of your head for a second. They're equal to each other. Set them equal to each other.
equal side, side.
8x minus 9 is equal to 6x. You can use hypotenuse length on this, yes, to make them congruent triangles too, but we don't actually need to go congruent triangle. I love that you're thinking that way.
X equals 4.5.
Okay, so subtract 8x. Negative 9 equals negative 2x. Divide by negative 2, we can write it like that, dividing both sides of the equation that way if you want sometimes. It's kind of a lazy way to do it. X is equal to 4.5. Were we asked just to find X?
No.
No, we gotta plug it in.
PR.
Okay. If you want to call it 2 instead of 4.5, you can call it 9 over 2, right? Sometimes we might prefer that. Okay, maybe like y. Okay, y would be like, well, if I'm plugging it back into 6x. Personally, I'd rather multiply 6 by 9 over 2 than by 4.5. Because 9 over 2, excuse me, cross simplifying, heck yeah, 3 times 9, that's 27. Okay, I like that. Okay. But if you want to, you could also do 6 times 4.5. Actually, I would probably do it the other way around. 4.5 times 6. Okay, 5 times 6 is 30. 6 times 4 is 24 plus 3, 27.0, 27. So the measure of PR is equal to 27.
That's not, no.
What are you asking?
You just selected it in the QR.
Oh,
We
I
related
did, didn't I?
PR. What are you doing? Stop it. How did that work?
They're congruent.
they're congruent.
Oh, yeah.
So I just picked the easier one. Because would you rather multiply by 6 or multiply by 8?
Well, no, it's supposed to be PR, okay? Just do PR.
Okay.
Oh, but no. Thank you. That was more difficult.
It was more difficult. But we checked our work too, didn't we?
We
What happens if they weren't the same?
Then you did it wrong.
Stupidly wrong.
Well, you just
Okay, that's true. Just be marginally. Like butter, baked butter, margin. say you only need one laugh for a joke to be good. Oftentimes on my own. Question on example 1. Okay, so how we got there, guys, the setup of it was we had to know this was a perpendicular bisector. From there, we know, okay, well, if R is on the perpendicular bisector, it's equidistant from the endpoints of whatever it's bisected.
Seems fair.
Okay, good. The theory's an aux, though. Okay. In the diagram, line JK is the perpendicular bisector of segment GH. Line JK is perpendicular bisector of segment GH. I'm always a huge fan of labeling pictures. What can we label on here? What do you think? Give me one thing we can label. Sarah.
Line segment JK is congruent to line segment KH.
Awesome. JK and KH, the segments. Segment GK, I said J, didn't I? Segment GK and segment KH are congruent. Great.
Angle JKG is
Yep, this is the right angle. Angle JKG. Very good. Okay, what's another thing we can label? Sarah?
JK is congruent to JK.
Okay, it's congruent to itself here. Sure. Okay, what's another thing we can label? Jay Lego Stevens?
GF and HF.
Okay, GF and HF, if as long as they're 4.1. So we know this has to be on the perpendicular bisector because they're congruent to each other, they're equidistant. Okay, yeah, that one's still equal. So FK is congruent to FK. Okay, what's one more thing we can mark congruent? Alyssa? Okay, FJ is congruent. Okay, FJ. I'll show you 3 tick marks. 1, 2, 3, 4. Holy God, I'm getting a lot. Okay, what else can I mark congruent? Sarah?
Line segment GJ is congruent to
JH. Yeah. Okay. Woo! We have a lot, don't we?
Wait, can we do? Oh, wait.
On number 1, what segment lengths are equal? We're gonna have to list a lot, don't we?
Yeah.
Okay. I'm okay with you guys this time. We're gonna list like 2. Actually, here's what we're gonna do. C.
Yes, can I do that on all?
No. I'm just giving you guys a freebie on this one. That's nice.
No, it's fine, because you don't want to write all of that.
I mean, I don't, but I already wrote it all too when I filled out the notes.
Why would you do that to yourself?
You're right, scrub.
That was really mean.
Boom, sucker.
Yes. Okay. Find the measure of GH.
Well, x equals 1.
How do you know that?
Well, 2x equals x plus 1 from there. I just need some mental math.
Yeah, 2x is equal to x plus 1. We have these because these segments are congruent. GK and KH. We find x, then we can plug it in and find GH. Okay? Subtract x, subtract x. X is equal to 1. Okay? So what do you have to plug it into in order to find GH?
So G,
You have to plug it in GK and KH, right? Now, could you technically plug it into 1 and double it? Yeah. But could you check it work by plugging it into both? Yeah, okay. 2 times 1 is 2. 1 plus 1 is 2. So what's the measure of GH? 4. What did you get it from? When did you get it? 2 weeks ago? So it's been a while. Okay, gotcha. I noticed that the big thing right now are perms and bullets. It's kind of
I'm not
interesting.
big.
Okay,
I'm really
The
not.
perms I'm a little bit okay with. Some people can pull it off, but mullets are just.
They're really not big enough. Did you know your necklace is backwards?
No.
Okay.
Nobody can pull off a mullet. Let's be honest.
Well, no, because it's attached to your head.
Yeah.
Okay.
Ha 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 ha.
Assuming you guys realize I'm just a super comedian. That's all I'm
You are not a comedian.
Okay, and look at these following pictures. In each of these, segment AB is a perpendicular bisector. Segment AB is a perpendicular bisector to each of these triangles. What do we notice about these perpendicular bisectors?
The one on the far left
They're not
they don't
center.
all make triangles.
You know what?
Not all in the center.
They're not all in the center. They don't all go. Fight! 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 Hey, you guys can both go. I'm surprised you guys are using a separate bathroom. has one.
Yeah, but
Usually you,
I used all the
right?
spaces because I let
Yeah,
everyone
Maggie stole mine.
Yes,
Fight. Yes. It doesn't always go through the vertex, does it? It doesn't always go through the vertex.
And not.
Okay.
That means that at least some of them plus the muscles.
No, they're also triangles. But that just would mean if it goes through the vertex, then we know the vertex is on the perpendicular bisector, so we know it's isosceles. They're still triangles though. If I cover this up, you'd be like, oh, it's a triangle. Yeah, so let's make them. Oh. Oh, sure. Okay, I understand. So it doesn't cut it into two triangles. Alright, sure. Okay. So the thing I want to take you away, want you to take away from this, the thing I want to take you away, the thing I want you to take away is the perpendicular bisector in a botch. The perpendicular bisector does not have to go. Does not have to what?
Do you drive a white van?
No. My dad does.
I know.
Oh, God. Okay.
But your dad drives a white van?
Yep.
Are there windows inside white van?
Yes, unfortunately. No.
Mr. Costa, I actually
Unfortunately, does not have to go through the vertex
Mr. Costa.
of the triangle. What? He doesn't pass out candy, guys.
Oh my
Okay.
god.
Well, what does he pass out?
Do you want my work that you never collected before mine? I
Yes.
forgot about this.
Yes.
Let me
Go
just
sit
put
down
on
on
your.
top.
I'm not sure any of it is right, but you know I don't really care.
I'm not
Show
sure.
your dad goes right here. Probably.
I'm Kevin.
Probably. Why did you have to say probably?
No, I mean it's just okay. It's like my dad he holds like a trailer with these vans like for his work, and so like he has vans because he has a crew with him, so we haul more people, and so there's like one of the vans happens to be white.
Sure.
That's the reason. Yes.
Maybe your siblings aren't really your siblings, you're just kidnapped children.
I'm pretty sure.
What if they were adopted? How would that make you feel right now?
Oh, I would feel really bad.
Think about that. Okay. We're gonna come back to this part later. Okay? Don't cross us out. We're gonna keep going. Don't worry. We're gonna come back to this part later. Okay? Just this bisecting segment part, we're gonna come back to it later. Okay? I think we'll have more time next class. We're gonna come back to it. I just don't hear it probably.
It is cold.
We're gonna finish this.
You just look at my
Lots.
What? Calm yourself. We actually don't have a ton left. Okay, we talked about perpendicular bisectors. Now we're going to talk about angle bisectors. We have an angle bisector theorem. First of all, what is an angle bisector? What does it cut in half? An angle. Cuts an angle in half, right? An angle bisector is going to cut an angle in half. Well, that's convenient. You can go when one of them gets back. It better be okay.
Excuse me?
Excuse me? Anybody think that's perfect? Okay. Excuse me? Okay. I will turn into my stool. Okay?
Doesn't the
Do
vlog
I have
say
to use one
that?
from my
Yeah.
It's like something you click.
Angle bisector theorem. If a point is on the bisector of an angle, D is on the bisector of an angle. If a point is on the bisector of an angle, then it is equidistant. There's that word again you guys love. It's equidistant from the two sides of the angle. If a point is on the perpendicular bisector of an angle, or excuse me, if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. And we measure distance. Distance is measured along the perpendicular. What that means is we do the shortest distance, the perpendicular distance. So, here, if measure of angle BAD, okay, measure angle BAD is equal to the measure of angle CAD, then we know this is the bisector, because we know it's cut in half. And so D is on this bisector. So this theorem says if we know D is on this angle bisector, then we know that DB is going to be congruent to DC. What's up, ladies?
He really just called you rats. What?
No, Justin did.
Justin, stop being.
Did I
You just said the
Oh, I'm
name.
sorry. My bad. My beat.
Justice.
Hey,
Make me, James.
I own it. My bad. I'm London. Okay. So we're saying if point D is on this angle bisector, then it's going to be have an equal length, equidistant to both sides of the angle. So it's the same distance to side BA as it is to side CA. So DB is congruent to DC. That's all marked in the picture there, okay? Now the reason we measure distance along the perpendicular, okay, the reason we measure distance along the perpendicular, aka to where this is a right angle up here, is because that's going to be the shortest distance. As we said, it's equidistant. Well, someone might be wanting to say, well, so you're saying this and this are the same distance? Those don't look the same because they're not. Okay, they're not the same. But we measure along the perpendicular because that's the shortest distance. If I am going to walk to this wall, what's my quickest route to get to this wall?
Obviously, going to the other one.
Straight, to where it's perpendicular with the wall. Okay? I'm perpendicular to the wall now. I'm not going to go at it this way. That's going to be longer. I'm not going to go at it this way. That's going to be longer, okay? Same kind of thing. So the quickest distance is going to be to where it's perpendicular to it. I write it like the same way I write my B's.
No!
So weird.
Bad!
Okay, wouldn't it make sense though that my B's and D's would be written similarly?
I was checking because I wasn't sure if you did.
Okay, continuing. Angle bisector converse.
That's disgusting.
If a point is on the interior of an angle, if a point is in the interior of an angle, like D is the interior of the angle right now, and it's equidistant from the two sides, along the perpendicular again, then we know it's on the bisector of the angle. So it just goes the other way around. The original angle bisector theorem says, hey, if a point's on the angle bisector, it's equidistant from the sides. This one goes the other way around. If a point's equidistant from the sides, then it's on the angle bisector. So here, this should actually be segment. If segment DB is congruent to segment DC, then we would know the measure of angle DAB, that is congruent to what measure? DAC. Measure, or I shouldn't have put measure there.
Damn.
Is congruent to angle DAC. I don't need measure there if I'm saying congruent. Let me just rewrite that.
Oh, you tried writing it like you did. It's just not.
Okay, if you really think about it though, it makes like a lot less work.
It is. It's like it's way
Because
easier
you're not
to
going
write
back
mine.
up
Agreed.
to write
What
it.
is it?
You're
Wait, do you guys go like this?
Yes!
Yes.
Why would you do that?
That is how I learned it.
That's how
Everyone
they teach
does.
you to do it.
That takes so
That
much
is
more
how I
time.
learned it.
Just go.
Wait, how do you do it? Do it again.
He doesn't line and then goes back
That
up.
looks just.
It does. It
It
looks
just looks
different.
worse though.
It
Wait,
doesn't look
that
good.
Why
Wait,
did you
that's
connect it
not
to how I
okay.
learned it?
That is so a D.
What if it's like a really bad.
What about
banana?
this? What about this?
What
It
if
looks
you
like a
missed
really
the
bad
top
what?
banana?
No, like banana would look like this, wouldn't it?
What if you miss
That's
the
what
top
she said.
banana?
What?
It looks like a very bad
Bananas are curved
What if you just go like that? That's curved.
You're on it.
on one side, like a D should be.
No! Bad!
That one just looks like half of a heart.
Like a shark.
You just make a circle.
Then I guess I'd rewrite. I don't know. If I went like this,
Yeah.
then I'd just go back. Boom, it's fixed.
Wait, no, but what if you go down and just.
I don't need that from you. Ugh.
They're both
Here I am with all these D's. Okay, continuing on. Okay.
Sounds like a good Saturday afternoon to me.
Dustin, real talk? No. Hey, no. Okay. Continuing on. Example 3. We're deciding whether this information below allows us to conclude that C is on the bisector of angle A in each example. So in 1, 2, and 3, we're saying is C on the bisector of the angle? Okay, and we would know that based upon the converse, the angle bisector converse. So in example 1, do we think that C is on the bisector? And if so, why? If not, why?
Yes, because 3 centimeters on the side.
Yes, because it's congruent to both sides, equidistant to both sides. So yes, it is, because it's equidistant to both sides. According to our converse, that's what it says. Okay, what about example 2?
No.
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 4 and 2 aren't the same, right? Okay, so no. What about example 3?
Yes.
No.
Yes.
No, because
Yes.
no wait, yeah.
I don't
Yes.
know.
It is.
It's not on
Rachel,
the
what are you
list.
saying?
No,
Why not?
because the line in the middle doesn't even match up with the.
Okay, the line in the middle doesn't match up. Okay, we're not actually as concerned because we don't know this line in the middle is the angle bisector.
Yeah.
Okay, so we're not concerned with that. This is 3. This is 3. How do we measure that distance though? What kind of distance?
Equid.
Eat the shell.
Equidistant. What kind of distance did we have here and here?
That one was not equidistant.
Right.
Right angles. Do we have any right angles here?
Oh,
No.
Do we know these are the same angle?
No.
No. So we don't know what angles we're talking about. So no, this isn't enough.
Oh, that's why.
So even though we see 3 and 3, we don't know the angles. We want it to be that right angle, so we actually know. We don't know it's right angle. We don't actually know. Okay.
Mr. Costa, do you like pistachios?
Yes.
Do you want one?
Sure.
You eat it with a straw.
How do you write your P's?
I don't
Okay.
salt.
They're not salted.
He
They're.
just ate the shell of a pistachio.
Like I put them in my mouth.
You did? You break it apart.
Why don't we sell salt? What?
Just
I don't think that's salt.
No.
Yeah, well, it's
Because like salt isn't as salty for you as non-salted.
Okay, I don't care. If I'm gonna eat a pistachio, it better be salted.
What?
I don't remember
I can't
asking.
believe you right now. You guys,
Okay, Brady.
what is the huge deal with like salted and non-salted nuts? Like I think
Tastes better.
they.
Rowan.
So,
Salty. Yes.
But, okay, so if they're not right angles, what if it's like just the, what if they have like marks on
If they were marked congruent, that'd be good enough for us. Yep, great question. If they were marked congruent, that'd be good enough for us. Because we could actually go through and we could actually end up.
Good job.
Actually, we couldn't group the triangles from there. That was a wrong thought. But we could go through
Ow.
and we could say because those angles are the same, that would be enough. So if we know those angles are congruent here, that'd be enough. We don't know. Good question though. I love that. Great.
How do you write your P's?
How do I write what? I'll do that later, I guess. Okay, we've gotten too many distractions right now. Move on. Example 4. How could we find the measure of CD? Okay, we're doing examples 4, 5, 6, and then we're done for the day. Okay, example 4, 5, 6, we're done for the day. Okay, how could we find the measure of segment CD? Okay, Sarah.
Set them equal to each other.
Set them equal to each other, okay? We're also told they're congruent here, but do we even need to know these tick marks here to know they're congruent? No, because it's on the angle bisector. 3x plus 5 is equal to 6x minus 7. What do we get x to end up being, guys? I heard 4. Okay, so 3x is equal to 12. Yep, 4. What do we do after we find 4?
Plug it in.
Plug it in, right? What do you guys end up getting?
17.
17.
Yeah, I heard some 17. That is correct. Okay, if you plug it into both of them, do you get 17?
Yeah.
Good, you did it right. Okay. Question on that one? Okay. On example 5, how could we find x? What do we know about these two angles?
They're equal angles.
They're congruent. Equal angles for polygons that have all equal angles.
That's
Um,
congruent. That's what I said.
So we know these angles are congruent. How do we know these angles are congruent?
Because it's bisected.
How do we know it's bisected?
Because the two lines are equal distance.
And
they
these
have
two
the same
lines
angle.
are equidistant from a point on this line.
Yeah.
This line must be a bisector. Very
I
good.
know what I'm talking
So
about.
3x minus 5 is equal to 2x plus 5. So we can't just assume things, but we can go through and figure that out from the picture. Does anyone have any questions on how we figure that out from the picture?
No.
Okay, go through and solve. Subtract 2x, subtract 2x. X minus 5 is equal to 5. Add 5, add 5. X is equal to 10. You get to plug it back in?
No.
Okay. I want you guys to try example 6 on your own real quick. Okay, once you have it or have questions, raise your hand. Okay? You want to check? You want to check? That's a weird box. You want to check?
So we're done now.
Why is it in color?
Because I printed these last minute.
Why do you give me 3? There's only 2 people in my row.
You're such a snub.
Oh, we'll need one for,
yeah,
for,
yeah, yeah,
Mr. Cox. Oh, I just did it.
Yeah,
I have,
that's-
like, peanuts.
You're right, I need to. No, you need to raise these now. Well, it's one of them. Thank you.
Oh, you just told me. I'm sorry about that. Sorry about that. We'll give us an instrument.
Hey guys, I have I have a note on number 6 for you guys. I have a note to give you on number 6 here.
Can
Okay.
you do it?
So no, on number 6, we need to know that segment PM. Okay, one second, guys. Before we go, let's write down this note real quick. Okay. Segment PM is the perpendicular bisector. Is the perpendicular bisector of segment LM. We need to know that information. Okay, you need to know that information on number 6. Okay, if you want to take a picture of that, you're welcome to. Okay, if you want to take a picture of that, you're welcome to.
So I'm assuming our test will be anytime soon for you to come back.
What? Yeah. Yeah, let's stick with a few C's. Okay. Rain wants to see my PA again, so anyone who wants to watch me draw my PA again, so you guys can laugh, go ahead. Okay, you ready for this? This one I do go back up because you have to.
No. Why do you go back up and not detach?
Actually, Mr. Costa, you don't have to go back up. You could just do
Yeah.
it. You could just start from the bottom. Yeah, you could just start from the bottom.
Yeah, but I'm not using those other ones.
What about C?
That's what you do with your D. What do you mean?
Okay, at least you don't go like upwards. That'd be really weird. Yeah, that's
Ah.
No, someone the other day in my class drew their S's like,
Oh.
right? That made me uncomfortable. That's what that
Now
sound
you know how
warranted.
we feel.
I don't need that sound on like my D's, but on those S's, I'm fine with that. The other one was a little aggressive. Probably. Okay. Sure. Alright. You guys want me to draw the letters? You guys good?
Okay, wait, but if you go back up with your D's, you go like this, D's, don't you? Oh.
It's so much simpler, but it's like unnatural.
Ah! It's a
Don't do that. How do you write your lowercase?
That's a short one.
No.
Oh.
That was right. I did that and I instantly regretted it. That was right.
B looks like a shark.
How did I not write it?
Okay,
You guys have to count that.
that's not how I write it, but normal.
Thank you. Yes.
Wait,
Yours started like
Your B looks like a shark.
how do you write your
On
A?
what?
on like
On my D, I do. On my B, though, I don't.
How do you write your A's?
Lowercase?
Okay, so that's how you write. That's normal. Okay.
There are different ways to write the uppercase A.
Yeah, there's like so
You can start at the
tail.
top.
I think somebody start at the bottom.
There.
Go up.
I just have a question on.
Oh, on the actual homework?
Yeah, I know, right? Okay. These are not.
Those are all right.
Yeah, but they're not.
Correct, yeah. So like, it's like a different setup for each
Yeah.
one. Like if this, if this, if this. Yeah.
How do you write a lowercase q? Okay.
Well, that was more of a tail than I normally do.
Okay, Betsy, calm down.
That'd be Betsy.
She's not even. I guess that's.
No, Betsy. Is this how you write your Q's? You know, lowercase Q's? Oh, that's weird. Do you just do B's because that's like the start of your name?
In line.
Oh, you do your. I forgot about that. I remember that from algebra. And your name, duh.
No, Alvin says, hi, hold on, I'm still following the tail.
Oh.